Good morning, it's Ty Warner with KISSsoft USA. Today we're just going to do a quick little exercise in the analysis of a given pair of helical gears. So a lot of times we have clients calling up and they say, hey, I've got this gear set, how do I analyze this in KISSsoft? So it's a fairly, it's not a daunting task, and it can be done fairly quickly and very accurately. So typically we'll end up with a given pair of helical gears. So many times guys will have something that's in production and they want to check it. In this case, we'll call it this exercise 1. We have a pair of gears. This is the power that we're having a look at here. It's 205 output speed, 500 hour life. The application factor is 1.5, so it might be something industrial with some, maybe a gas engine is driving it, or maybe it's in a pulp mill, something like that. We can see it's 20 horse. We can see that we have a known diametral pitch, a helix angle, we have a pressure angle of 15 degrees. We have the teeth numbers, the face width. This is in inches, by the way. We have an accuracy grade. We have a tooth trace on here also that's crowned, and we'll go through that as well. Some of profile shifts, those are given. That's important because we're going to end up clicking a couple things in our toggling a couple of options in our module specific settings in order to add those. We also have the material, which is a 42 chromo 4. We know that it's oil injection. It's 120 degrees F. It's a VG 150. And we have our two thickness tolerances here, which is a DIN 3967 D25. And we are using a 2001 D04 on our strength calculation. So the first thing we do is we open KISSsoft. And I'm using KISSsoft 2016. You can tell that by this number up here in the upper right corner, release 03-2016B. At the date of this recording, B is the latest service pack that we have installed. So we are up to date, and this is KISSsoft. First thing we do here is we open up our cylindrical gear pair, and that's the same for spur end or helicals. Double click this, and we have our basic data page. I'm going to go ahead and go to Extras, System of Units. I'm going to make this US, Customary. Now our module specific settings, because of what we talked about previously, we are given diametral pitch, and we are giving the profile shift coefficients. So I'm going to go to my calculation. I can go to my specific settings this way, or I can grab my specific settings right here. We want input of normal diametral pitch instead of module. So I'm going to check this box. I'm just going to go ahead as a habit to allow large profile shift. And the calculations, we're going to calculate with the operating center distance and profile shift according to minutes. What this tells me is that I can use the profile shift according to manufacturer, and the program won't just calculate it, and then I'll end up with a center distance that I will allow the program to calculate since I don't have that. So we click this, and we say OK. So our normal diametral pitch is 10. We have a 15-degree pressure angle, and that was a given. We have a 20-degree right-hand helix. This is for gear 1. So we go right-hand helix, and it's a helix angle of 20. That's already there. We don't know what the center distance is, but I do know the gear teeth numbers, which is 21 and 82. I also know what the profile shift coefficients are, and those are 0.45. So I enter the first gear. You see this is grayed out here, but if I unclick this box, now it isn't. So now I'm going to enter the second one, which is minus 0.2510. Now I'm going to size the center distance. And then the sum of the profile shifts right here, 0.1990. That was a given as well. I calculate the center distance, 5.5 inches, and I accept. Well, look at this. We got a quality in the AGMA 2015, so I need to change that in my module specific settings. This is going to be 7, so I'll just go ahead and put 7 here initially. But then I'm going to go back up to module specific settings, input of quality according to calculation method, and I hit OK. AGMA 2015 quality 7. Alright, I need to now set my material and lubrication, and I can do that right here. I hit plus so I can see this nice big information. I'm looking for 42 chromo 4, and I need a 145,000 ultimate and an HV of 550. So there's a couple ways you can do this. You can do a surface hardness, unit of hardness. You can go from top to bottom, or you can find that information over here. So we start at the top, we come down, here's a 30, 34, 25, and we might not have that grade in here. We have 18. There's some plastics. Okay, so what I need to look at then is I need to look at the core hardness, and I need to look. It's a nitrided. So what I can do then is I can say I'm looking for a nitrided steel. I don't know what material type. It's not going to be through hardened. It's not going to be case hardened. Nitrided steel. Here's a 570 and a 32 chromo 13, and 130 is my SAT endurance root, which is 53,000. This is pretty close. It's a little better steel than I was looking at, but we can use this. It's pretty close in hardness. Again, this is a set that we have, and we can enter that other material because I don't think it's in here. So we definitely wanted a nitriding steel, and that's what this is. So what we're doing is we're making an engineering assumption that this is pretty close, and we're going to use it because it's going to give us a good idea of what we want. So I'm going to use this 32 chromo 12 instead of the 42 chromo 4 because it's pretty close to the core hardness and the surface hardness that I want, and it's a nitrided steel. We hit OK, and we're going to do the same thing for the other gear. We're going to come in here, we're going to come down, we're going to find our DIN 32, chromo 12. Figure 13A, 14A, which is this one. We're going to say OK. We're now going to enter our lubrication, which in our example, we are using a VG 150 at 120 degrees F. So we go back into here, we find our VG 150 right here, and we say OK. And we're going to say it's an oil bath. We don't, well, it's an oil injection, I guess. I guess we did know that. So we're going to say it's oil injection. And we can hit this little plus button right here. And we can add 120 degrees F. That's our lubricant temperature. I guess that would be like a bulk temperature. And if you're not sure, you can click in this box and hit F1. And we get a manual that comes up that talks about the lubrication is in here somewhere. But we want 120 degrees F. So, and we're not going to be putting in a load spectra at this time. We're just going to use a single load. So we say OK. So the information is now calculated and input on the basic data tab for that gear set that we have. Well, I need to put in the face width, and it's 2.6 and 2.5 inches. Don't forget that. And then we can calculate. And it's telling us right now we didn't go to the rating tab and put any information in there. So we say, OK, let's go to the rating tab. The other thing it's saying is we want to calculate according to 2001 D04. So the first thing we can do is we can say, well, we're going to calculate 2001 AGMA D04. This is our strength calculation method. Micropinion is going to be this. We're going to leave it at ISO. Tooth flank fracture, we're not going to do this one. I suppose we could, but it's a little bit more in depth, and we have a nitrated surface, so that's really not what we're looking at this point. The working gear is gear 1, that's driving. We know we have 20 horse, and we know the speed is 205 output. That's it. Gear 2. And I say that because if we look here, it tells us the speed output is 205. The power is 20. So our input speed's got to be whatever that ratio is. We have a life of 500 and an application factor of 1.5. So we change our required service life to 500. We adjust our overload factor or dynamic factor to 1.5. And now we are not going to consider the load spectra, although we could. But this case we're not going to. Now we hit calculate, and it's telling us that the endurance and ultimate material data may not match the values stated in AGMA 2001 or 2101, but that's okay. What we have now is we have a basic design. We have tip circle, we have root safety, flank safety. I've actually modified my results table to give me some sliding information on it. This 3 feet per second is pretty fast. I would normally try and stay below that, but this is the gear set they gave me, and so this is the information I have. Okay, and we are saying the driving gear is gear 1, but the reference gear for speed and power is this. So if I change this to gear 1 now, you can see what the input torques and speeds are. What was also in part of our design information is we have a reference profile. And we're looking at a reference profile of 1.25, 0.25, and 1. So we go back to KISSsoft, and we go to our reference profile, and we can, and that's a factor, by the way, the 1.25, 0.25, and 1 is a factor. We can look in here, and right here, this profile C matches our reference profile given. So we go ahead and change that for gear 1, and we go ahead, go to gear 2, and we also change that to 1.25, 0.25, and 1. Now we can calculate. We have a couple things that updated. Maybe our actual tip circle data changed a little bit. Max sliding velocity hasn't changed too much, but that's all right. The next thing we're going to do is look at our tolerances for tooth thickness, and the tolerances they gave us were right here on the bottom of this page, a DIN 3967 D25. That's for the tooth thickness, but we also have a tip diameter deviation and a center distance deviation, which we can input on our own. So if we go ahead and go back, we can give our tip diameter allowance, upper and lower. And it's 0 on the upper and -5 on the lower. And we're going to do that for both Gear 1 and Gear 2. And Gear 1 and Gear 2 are the same tooth thickness tolerance, by the way. And that's the assumption we're making. And then we have a center distance allowance right here. And this is going to be our own input because it's just giving us a +1, -1 thou. So we go ahead and change this to +1 and -1. Okay? That becomes our own input. And we go ahead and calculate this again. Not much changes. I kind of got her dialed in. The next thing that we have to look at now is we do have crowning as far as a tooth trace. We don't know how much crowning we have, but we definitely have crowning. In this case, we're going to allow the program to make a recommendation, and we're going to take that recommendation. So we go ahead and go to our calculation, and we need to add in modifications. Okay? On our modifications here, this is going to allow us to put our crowning in. And if we look at our factors, we need to decide exactly what kind of a gearbox this is going to be. We're going to have crowning or helix modification. We're going to use a face load factor according to the calculation. And we're going to say that this is well, we don't know for sure if this is a industrial gearbox, but we'll say it is it's a commercial enclosed gear unit. And we're going to say that the contact pattern is probably not improved. But we'll say we set them at the assembly. Maybe it's improved in terms of maybe they shim it, plus or minus. I don't know. We can look at our gearing information here. We're going to say that it's basically A is 0. This is looking at this one here. Our offsets aren't too bad, so we're not going to change this. We're going to say that our offset is small, so it's less than 1.175, and that's the offset for the gear on the shaft. Okay. Our general factors, we're going to allow the program to calculate the transverse load, the dynamic, and the face load factor. So now if we run this, we have a 1.1903. You can see our root safeties and flank safeties haven't changed much, but now what we want to do is we want to go in here and we want to add our crowning. So a quick way to do this is we go ahead and allow the program to size our modifications for us. So we hit size, and we're going to say tooth trace modifications, because we're not doing tip relief or root relief. We're going to do tooth trace modifications as far as crowning, and it's going to be crowning only. So we're going to do crowning ISO 6336-1 Annex B. We're going to consider maybe 50% manufacturing allowance. We're going to calculate. Oh, it doesn't like that with that. So in order to do our crowning, what we're going to want to do then is we're going to change this. We're going to cancel And just for our crowning, what we'll do is on our rating, we will profile modifications, no. Okay, that's all good. We'll change this to ISO 6336 method B. Okay, when we do this, we get a different flank and root safety factor, which is fine because we're going to go into modifications. So that's the AGMA downfalls. We can't do modifications based on that. But now since we've changed that to 6336, we go in here, we do a calculate. The value is very simple. So you'd want to, if you want an exact calculation, we want to go into the module, shaft module. We're not going to do that, but this is giving us a value. We're going to say accept, and now we have crowning on both gear 1 and gear 2. We're going to accept that. Okay. Now we're going to go back to our rating, change this to AGMA D 2001 D04, and then we're going to calculate. And we have our flank and root safeties according to AGMA. We also have our max sign velocities here. There's another video out there I put in there as far as modifying this window. You can put whatever you really need in here. At the end of the day, I would say this is a completely entered into KISSsoft here. We have our basic data, our profile shift. We know our pressure angle and normal diametral pitch. We have our number of teeth. We've calculated a center distance according to that. We've specified the reference profile. It's actually a profile that's out in the world, profile C. So it's not our own input. We specified our tolerances for the gear tooth thickness according to this DIN thickness tolerance and according to the tip diameter allowance, which was also information that was given to us. We also have our own center distance tolerance, which was information that was given to us in the design pair. We added a crowning according to the calculation method. We did have to change the rating method from AGMA to ISO in order to give us a rating that way. But then we changed the rating back to give us our final result. And that's just it's just the way the standards are written and how those standards are used. We entered our information that we were given for the speed output and the application factor and the desired required service life. We also added our tooth trace modification for crowning. It was a commercial enclosed gear unit, and our contact pattern was set at the assembly. We also added our materials or comparable material. We could add our own material. There's another video out there if you want to look at that on how to add your own materials. We added our lubrication, the type of lubrication, and the temperature. And that's it. So I've basically gone through a simple analysis of a gear pair that maybe you have in production, or maybe someone's asking you, can you reverse engineer this? Can you tell me why it's breaking? What is the information you have? And that's how we would normally analyze a quick pair of gears in KISSsoft. There are some other things you can do. You can look at geometry in terms of meshing. So you can look at the gear pair itself. Okay, and you can see the tooth form. You can look at the cutter tool if you want. Oh, it's somewhere in there. Manufacture the gear 1, so it gives you the gear 1 manufacturing. And also you can look at the profile diagram, and we have crowning in here, so this might be of interest to you for gear 1. If you don't like these, the DSA, DNA, you can go to your module specific settings. Oops. Module specific settings, and you can go to your, let's see, is it summary? No. calculations, we want to look at things in terms of what's in here. We want to use start of active profile, end of active profile instead of DFN, DNF, DNA, so you can toggle that. You can also change the diameter markings on the excuse me, to roll angle, to length, angle of rotation, or no marking. At this point we're just using diameter. The y-axis is, I mean, these are things that you can adjust in terms of what your diagrams look like, okay? And you can also adjust your helix angle, modifications, and your contact analysis stuff. So you can either do a modification. These are things that you can do. You need to know what you're doing. And then what this is saying is to display profile in the middle of a tolerance band. You can if you unclick this and you run this is our profile right now, right in the middle of the tolerance band. This dotted red line. Okay, now this is your profile. And you can see that we have a start of active profile, end of active profile. And this is a crowned gear. So this would be your tolerance in millionths of an inch in your right tooth flank. Same thing for gear 1. When you have a tooth trace diagram, now you can see what it looks like in terms of the across the face width, and you can look at the drawing. Well, there's not much information there that you're going to glean out of it. Drawing gear 2, flank curvature, if that's something that's important to you. Manufacture of gear 2. Some other things you can look at. You can look at evaluation of specific sliding. Normally, for my taste, I would try and balance this out, get this a little bit shorter. 0.7 and minus 0.7 maybe. You could do that in fine sizing if you're going to make changes. The report, you can now generate a report. You've got all the information in here. If you generate your report, one of the things that I like to do is go to extras, go to settings, and I like to use an external editor for my report. Okay. And the reason I do that is because then I don't lose my data input windows. So I hit OK here, and if I generate a report now, which I'm doing, here it is. I get this data window that comes up, and it says it's going to tell me these values for the endurance limit and the yield stress for the material. Maybe it aren't match the value in AGMA, but that's the material we chose. And now it goes through all the information of the design. Okay, we have our profile. We have our transmission ratio. You can pull out the torque. There's no protuberance. We didn't do anything like that. You have your tip diameter, your allowance right here. We entered this in, right? We have our tip alteration, which was 0, our reference diameters, and our base diameters. Max sliding velocities. We have our length path of contact. Okay. Dimensional single contact point, it gives you, or the diameter of that. Transverse contact ratios. Lots of information. Tooth root strength, you can look at the stress. You can look at this allowable bending stress, temperature, etc. So if you have a material that's maybe a little bit less and you want to know what your, like I didn't have that 42 chromo 4 nitrided material, and the ultimate stress or the yield stress was 60 instead of 53, I can go ahead and look at my allowable contact, see my calculated stress for my root strength. which is going to be up here. Which is my bending stress number, 2 through thickness, bending strength, geometry factor, allowable bending stress. See, this is 61. And when we calculate the safety factor, you would take, for the root at least, in bending, you would take the actual bending stress and then you would divide the allowable bending stress by the actual. So 22,671 divided into 61,461. And if you look, it actually gives you the equation right here. The effective divided by the actual, the safety factor. So this is when we do an analysis, we make some assumptions about materials, and we maybe have to enter our own materials, and then we allow the program to, we work through the program to get our desired result. It doesn't do everything for you. You got to do some thinking about it, but it does a tremendous amount of reduction in terms of calculating it by hand and that sort of thing. It's a great program. If you need a copy of one, you can call KISSsoft. You can go right to their webpage, KISSsoft.com, and you can look at some of our other programs that we offer. This is Ty Warner with KISSsoft USA. Hopefully this has been educational and you can get something out of it. Thanks for listening.